Okay, we are still in our operations research course. Today we will talk about linear programming, a brief, fast introduction about linear programming before we dig into details about linear programming. What is linear programming? It's abbreviated as LP, standing for linear programming. It's known as a tool that you use to solve optimization problems. Back in 1947, George Dantzig developed an efficient method called simplex algorithm that's used for solving linear programming problem. That's called by that time until today as linear programming, or LP as known. Since it's been developed as a simplex algorithm, LP used to solve optimization problems in industries like banking, education, forestry, petroleum, and trucking. And up to today, there is a lot of engineering companies that are using linear programming to solve all kind of engineering optimization problem, or even cost optimization problems. So Fortune 500 firms, they made the research and found out that 85% of the respondents said that they had used linear programming. So there's 85% of the 500 most famous companies known in the market are using linear programming. So linear programming is a very important tool to know. It have a lot of applications in almost every aspect of science or in the industry. It's basically a problem that have a linear form, can be optimized to find like the maximized or minimized solution for a certain parameter, as we will learn as moving forward. So before we describe the linear programming, let's describe linear function. Most of us know from our mathematics background that a linear function, if we go to the definition in here, a function f of x, x1, x2, xn, that has x1, x2, xn as variables. It is a linear function if for some set of constants c1, c2 to cn, f of x1, x2, xn, the function equals c1, some constant multiplied by variable x1, plus c2 multiplied by variable x2, plus c3 up to cn multiplied by xn. As you can see here, all the variables are having a power of 1. That's why we call it a linear problem or a linear programming problem. If you have a function f of x1 and 2 equals 2x1 plus x2, that is a linear function of x1 and x2. But on the other hand, if you have an f of x1 and x2 equals x1 squared multiplied by x2, so you can see here the power is more than 1, that is not a linear function of x1 and x2. And we want to define the linear inequalities for any linear function f of x1, x2, and xn, and for any number b, the inequalities for f of x1, x2 to xn less or equal to b, and f of x1, x2, xn greater or equal to b are linear inequalities. So, as a quick example, if we take a function 2x1 plus 3x2 less or equal to 3, and 2x1 plus x2 greater or equal to 3, they are linear inequalities. But if you have x1 squared multiplied by x2 greater or equal to 3, that's not a linear inequality. So as long as the equation you're describing are linear, then you can call them linear inequalities. But if it's nonlinear with a power of more than 1, then we call it not a linear inequality. The linear programming problem itself, so we define the linear function, what is it, from a mathematic perspective, and we describe the linear inequalities. Now, the linear programming problem, which is the focus of this, which is part of the focus of this course, LP, it is an optimization problem in which we do the followings. First, we attempt to maximize or minimize a linear function. So you have a linear function, you want to either maximize a certain, maximize that function, like the final result to be maximized or minimized. So linear function of decision variables, the function is either maximized or minimized, called as objective function. Secondly, the values of the decision variables must satisfy a set of constraints. So that linear equation have constraints. Each constraint must be a linear equation or linear inequality. So you have a function, you need to maximize it or minimize it, and you have constraints for that linear function. Those constraints are represented in a form of linear equations or linear inequalities. Then you have, thirdly, a sign restriction associated with each variable. Each variable needs to be declared with a certain sign based on your problem. So for a variable xi, the sign restriction specifies that xi must be either non-negative or unrestricted in sign. So you have xi greater or equal to 0 or unrestricted in signs. More about the linear programming will be discussed in the future, and eventually our goal is to be able to solve linear programming problems and real life examples and see the benefits of knowing the linear programming and how to solve it.